Hi, Ron. How are you doing?
I'm good, sir. How are you?
Very good, very good. So, Ron, I thought we can look into inequalities today, right? You know about linear inequalities. We'll do inequalities using two variables, okay?
Okay, sir.
That is basically based on lines. I'll just teach you what it is. So, here is my lesson for today. Can you see my screen?
It is starting. Yeah, now I can see it.
You can see it, okay. So, let me put it like this. Okay, so can you read the title, please?
Solve inequalities. So graph linear inequalities, graph linear system, solve linear inequalities, quadratic inequalities, double inequalities, absolute inequalities, rational inequalities, exam practice, and word problem.
A lot of things, right? But we'll focus today on graphing linear inequalities, graph linear systems. We can do that. We can say solve linear inequalities, and we can also look into quadratic inequalities in today's class, right?
Okay, sir.
So the type of inequalities which you have already done are like what is when x is greater than 5? You know that, right? So if x is greater than 5, we can actually plot this inequality on a number line. And we say, well, on a number line, if this is 0, let us say, right? And let's say this is 5. Greater than 5 means it does not include 5, right? So
Okay, sir.
it will be open circle here, and that becomes greater than 5. Is this concept clear to you?
Yes, sir.
Right. So if I have x is greater than, let's say, -1, but it is less than, let's say, 2. So that means x values between -1 and 2, both not included, right? I could take this as greater than equal to. In that case, we'll include both the points, endpoints. So if I have to plot this on a number line, I will say, well, this is, let us say, -1 for me. And that is, let us say, 2, right? In that case, if we include them, we'll put in the filled in circle from -1 and 2 and join the line. So this is the interval which shows the solution of the double inequality x greater than -1 and less than equal to 2. Is that clear to you?
Yes, sir.
So filled in circle means the point is included. Open circle means not included, right? So this is open circle. Open means not included. And this is filled in.
Meaning included?
Yes.
So that would be like the greater or less than
Equal to.
equaled. So that would also consider as included?
Yes. So equal to,
Okay.
whenever equal to comes, then you have to equal to means that point also, right? Greater than means not that point, but greater than. Less than means not that point, but less than. So it will be an open circle, right? So with this concept, we'll begin and try to understand how do we graph linear inequalities, right? Now, let us further discuss when we are talking about graphing linear inequalities, what does it mean, right? You understand linear equations?
Yes, sir.
A linear equation is a two variable. It has two variables, right? Whenever you say y equals to mx plus b, that means it is a line, right? It is a straight line, correct?
Yes, sir.
If I
Linear
say
line.
y equals to, let us say, half x plus, let's say, 1, it means it's a straight line which goes through 1,
One.
has a y-intercept, and has a slope or gradient of half, right? So
Ah.
something like this, something like this. Is it okay?
Yes, sir.
Well, at this point, the y-intercept is +1, correct? And the slope will be half.
One over
And
two.
that is to say 1 over 2. That means if I move 1 unit to the right, then in that, I mean 1 unit down or up, I move 2 units to the right. That means this point will be what? This is 0. If I move 1 unit to the, up, then I'm going 2 down. 2, right? So it is 2,
2.
2. Is that clear?
Yes, sir.
So that means 1 up, right? And then 2.
Right.
So you reach a point which is x coordinate of 2, right? Similarly, if I go next step, then the next step will be that I'll go 1 up and 2 right? So I'll reach the next point, which will be not at 2, y value will be 3 for that. However, the x value is going to be 4, right? So it will be 4, 3. Is that clear to you?
All right, sir.
So that graph will have a slope of half. When I say an equation, then equation really means that all the points on a line, and therefore the line is that clear to you?
Yes, sir.
So that becomes the equation y equals to this particular thing, correct? So that becomes the equation for us. Now we are talking about inequalities. If I say that my inequality is y is greater than half x plus 1, it means what? Can you tell me?
Y is greater than half x plus 1.
1, right? So then we are looking into a region, right? Everything which is above this line, is it clear to you?
Yes, sir.
Everything above this line is what we are looking into, and line is not included. So we'll say a dotted line for this. Is it clear to you?
Okay, sir.
So the region above the line, is that clear to you?
Yes, sir. And if y were to be less than half x plus 1, then we'll look at it going down, sir?
Perfect. That is how it is going to be. So it is again called an open region. This is open half. So a line actually cuts the whole plane diagonally into 2 parts, correct?
Okay.
So when we say inequality, we are saying one of those 2 parts. One of those 2 regions is a part of solution. Is that clear to you, right?
Yes, sir.
Right. So our solution now is the upper half, since we are looking into y greater than the equation of the line, correct?
Yes, sir.
Okay. So now that brings us to what is a linear inequality. A linear inequality in 2 variables. So we have 2 variables. One is x, the other one is y. So the linear inequality in 2 variables will have these signs, correct? In between, they will not have just equal to. They may have greater than, less than, greater than equal to, or less than equal to symbols. Is that clear to you?
Yes, sir.
And the equations will be of one of these kind of types, right? So we have x and y values, which could be greater than or equal to the other side. So we have 2 sides to it, left side and right side. And in between, we have inequality sign. Is that clear?
Yes, sir.
So this is your inequality sign that makes us this inequality. So a linear equation divides the coordinate plane in 2 parts called the half planes. Okay. So these 2 parts are called the half planes.
Half planes.
A solution of the linear inequality is a region, not just a line or a point. It is a whole region, everything above the line. So the solution of a linear inequality is the region defined by one of these half planes, correct? So either it is the upper half or it is the lower half of the plane, which will be included as the part of solution. Is it clear?
Yes, sir.
Right. So inequalities with greater than or less than symbol will not include the line as a part of the solution. So if there is no equal to sign in the inequality, then line will not be included. Okay?
Okay, sir.
In that case, what we do is a dashed line is drawn as a boundary. So dashed line, just as I've drawn here in red, the dashed line as a boundary means do not include the line. So a dashed line is drawn as the boundary because it is not included as a part of the solution, correct?
Okay, sir.
Each part of the region is called open half plane. So we call it an open half plane.
Open half.
That boundary is not included. Is that okay?
Yes, sir.
Now, inequalities with less than equal to or greater than equal to symbol will include the line as a part of the solution. If you have greater than equal to or less than equal to, then the line will also be included as a part of the solution, correct?
Yes, sir.
So solid line is a boundary for the half plane, and we call this as a closed half plane. You get the idea?
Yes, sir.
So closed half plane means that the line is included, okay? So we'll take a few examples. Let us take this particular example, which says graph y greater than half x minus 2. So can you sketch this graph? Y equals to half x minus 2.
So y is greater than or it's just equal to?
Greater than half x minus 2. So the line will not be solid. Line has to be dashed line.
Dashed line.
So you should first draw y equals to half x minus 2 line. So it is, let us say, a line like this, right? Of course, you can draw this line. You know that the y-intercept for this line is minus 2 and the slope is half. If I put y equals to 0, I get x value as what? I could do like this, right? If y equals to half x minus 2, if I put x, let us say if I put y equals to 0, right? So let me write like this. I want to find the x-intercept, okay? So if for that, I put y equals to 0, I can find the x-intercept of the line, right? So I can bring this here as half x. And so 2 times 2 will be 4, right? So, I mean, I should write 2 times 2 first is the value of x, which is equal to 4, right? So x value is 4. So joining these 2 points, the y-intercept and the x-intercept, we can draw the line, which is y equals to, this is y equals to half x minus 2. Now we are interested in what? We are interested in a region which is y is greater than half x minus 2, right? Which region will it be? It will be upwards, correct? Open half, correct. So that will be the open half dotted line, the solution for the given question. Is that clear to you?
Yes, sir.
So that is how you actually graph the solution of an inequality on the coordinate plane, correct?
Okay, sir.
Let's take one more example before taking some practice questions. Now we have another line for you whose equation is 2x plus 3y less than equal to 6. So what do you expect? Do you expect open half or a closed half solution?
2x plus 3y 6. So I would say closed halves.
Yes. So we have to draw a solid line, right? That means solid line. Is that okay?
Okay, sir.
So let's draw the solid line first. So we'll draw 2x plus 3y equals to 6. How will you draw this line? Tell me.
I would solve for y interceptor. So x would be 0, then 3y equals to 6. So 2 would be the answer, sir. For
so y-intercept will be 2. Yeah, you're right. So y-intercept will be, you'll put x equals to 0. In that case, we got 3y equals to 6 and y is equal to 2. Correct. So you got the y-intercept, and let's say the y-intercept 2 is this point. Now, what is the x-intercept?
X-intercept would be 3, sir, because y would be 0.
Y
so then
equals to 0, 2x equals to 6, x equals to 3. So that is the point which is at 3, right? Somewhere here. So joining these points, we get our line, and we are going to draw a solid line, correct?
Yes, sir.
And since we are saying that this line is less than equal to 6, right? So whatever this line is, if I rearrange this, what do I get? I get the value of y as less than minus 2x plus 6, or y value is less than minus 2 over 3x plus 2. Is that okay?
Yes, sir.
So definitely we got the same equation, y-intercept being 2. Since it is less than, we are including the line for which region is shaded. The region below this region, right? So this half is shaded, and therefore we get our solution, which is a closed half plane. Is it okay?
Yes, sir.
Below the
So,
solid line. Clear?
so just to clarify, a closed half plane would always be a solid, and an open half plane would just be dashed.
Dash dotted. Correct. That is it, right? So now I think the concept is clear to you. So we can have some test type of examples. So here is the very first question for you to do. Can you please read the question, write the answer, and discuss with me?
2x plus 4 is greater than 10.
Less than 10.
Oh, less than 10.
This is a single variable inequality, right? Because we don't have y here, correct? So you have to write down its solution. Its solution will come on a number line as we discussed earlier, right? So let us see, how do we solve this? So we have this as 2x plus 4 is less than 10. We can take away 4 from both the sides, right? So we can write this as 2x is less than 10 minus 4, or 2x is less than 6. Dividing by 2, each side, we get x is less than 3, correct?
Yes, sir.
So x less than 3, can you plot this on a number line? Let me draw it here itself. If I have a number line here, let's say this is my 0, right? Let's say this is my 0. In that case, solution is x is less than 3. I'll have an open circle here, and I'll have a line which is going left. So that becomes the solution where the open circle is at 3. So that is the solution of part 1. Clear?
Yes, sir.
Can you solve question number 2 now and tell me the answer?
5 minus x divided by 2 is greater than 15.
2x, this one.
Oh.
2x plus 5.
2x plus 5 divided by 3 is greater than equal to 7.
Yeah. Next step, what will you do?
So what I would do is I will just
cross multiply.
I'll just multiply 3 on both sides, and then it would just be 2x plus 5 greater than equal to 7 multiplied by 3.
Perfect, perfect. So,
and then I'll bring the 5 to the other side, and then just continue solving to find x.
Correct. X will be greater than equal to, you can divide by 2, right? So 21 minus 5 divided by 2 is what the value of x is. It is greater than equal to, what do you get?
I'm still solving it, sir.
Do it.
Do you call it CRE?
Yes.
I got 8, sir.
8 is correct. 21 minus 5 is basically 16, and 16 divided by 2 is 8, and we have greater than equal to. So on a number line, how will you place this solution? Let us say this is 0 for us, and this is 8 for us.
So I'll put a closed circle, sir?
Yes.
Because it could be equal to?
Yes. And then draw the line going right as shown in the figure. Clear, right? That is how you're going to do it. Okay, now let's do the question number 3 and question number 4. So, okay, so question number 3. This is again a linear equation in one variable. So we have 5 minus x by 2. X by
2 greater than 15.
Yeah, tell me how will you do it?
So what I would do is I would do 5 minus x because we multiplied it. So on the other side would be 15 multiplied by 2.
So 5 will also get multiplied by 2. Okay. So if you want to do it, or you could do, take x by 2 on the other side. So you get 5 minus 15 greater than x by 2. This is a better step, right? So you isolate the variable and better take x by 2 on the right-hand side so that it becomes positive. Otherwise, when you multiply or divide by a negative number, you have to change the sign. So the better step is to keep the variable positive as we have done here, right? So now we know minus 10 is greater than x by 2, and now you can multiply by 2, both sides, correct?
Yeah. So it'll be negative 20, sir.
20 is greater than x, or x is less than minus 20, right? What
so
you say
it'll just
x
be
is less than minus 20, correct? So that becomes the solution of this particular line. So basically, on a line, what are you going to do? At minus 20, you will put an open circle and then move towards the left. Everything below minus 20 is a part of solution. Is that clear to you?
Yes, sir.
Perfect. So, Rohan, your connection dropped. So we'll start from here once again. So what we are doing here is question number 4 is an absolute value function. We'll kind of change this question. Is it okay? So we'll write this question as, let us say, y plus 3 less than 2x plus 1. So we have now an inequality where there are two variables, right? So we have two variables.
Okay, sir.
Can you suggest how to solve it?
So what I would do is I'll bring plus 3 and plus 1 onto one side. So it would be y is less than 2x minus 2.
So let me write plus 1 minus 3. So I'll get minus 2. Let me do it in 2 steps, right? 2x minus 2. That is clear. So basically, you get a region which is below a line, and the equation of the line being y equals to 2x minus 2, right? So the solution will be what type of solution? Will it be open?
It would be
or
closed?
No, open, because it is less than. We are looking for open region, right?
Okay, sir.
So that means a dotted line. Is that clear to you?
Yes, sir.
So let us sketch the graph of the line, and then we can mark the region on the plane. So it is 2x minus 2. That means slope is 2, right? So the graph will be open. So I'm making a dotted line. Let's say like this. To draw the line, I know the y-intercept is minus 2. I have to find one more point. So if I take x equals to 1, I get y equals to 0, right? So that will be the x-intercept, which is at 1. Is it okay?
Yes, sir.
So that gives me the line. So once I've drawn the line, I know y value is less than the value of the line. So which region should I shade?
You should shade the bottom region.
Bottom line or below the dotted line, correct? So that is the region which is being shaded. So open region, dotted line, below region, right? So below the line, right?
Yes, sir.
So that becomes a solution for the inequality which involves two variables. Is this concept clear to you?
Yes, sir.
So far, what we have done is we looked into inequalities with single variable and with double variables, or you can say two variables.
Okay, sir.
So when it is single variable, I mean one of those types, right? Or even this type, then the solution will be on a number line as shown here. Is that clear to you?
Okay, sir.
But if it is a double variable, in that case, solution will be as shown here as a region of the half, which is divided by the line, correct?
Okay, so if double variable, it would be graph, and if single variable, it's just number line.
Correct. Okay, now we look into the next question, which is a quadratic equation 4x squared minus 12x greater than 40. How are we going to solve this particular type of inequality? Can you suggest?
So 4x squared minus 12x is greater than 40.
Yeah.
Then what I would do is square root 4x squared.
Well, all the terms cannot be square rooted, so that may not work. So we have 4x squared. I could divide everything by 4. Do you see that? I could first simplify this. So if I divide everything by 4, I have smaller numbers to work with. Does it make sense to you?
Yes, sir.
So we get what? We get x squared minus 3x is greater than 10.
10.
Okay. Now, we know x square is a parabola and 3x 10 could give us a line, right? So we could rearrange this equation and write it as x square is greater than 3x plus 10, correct?
Okay, sir.
Right? We got x square is greater than 3x plus 10. So we have this thing. So I'm just showing you a couple of ways in which it could be done, right? So we could do it in many ways. So we will follow two methods. So I'm just showing you method 1 first. So we wrote it as a combination of a parabola and a line, which is 3x plus 10. So on a graph paper, what you could do is that you could sketch the parabola. Let me do it here, right? You could sketch the parabola, which is x squared. And then you could also sketch the line, which is 3x plus 10. Correct?
Yes, sir.
So when you sketch, you want the parabola value to be greater than the line, correct?
Yeah.
So where is parabola greater than the line?
The parabola greater than the line is after the point of intersection.
After the point of intersection, correct? So I could highlight this portion as open circle and like this. Is that clear to you?
Yes, sir.
So that becomes the solution of this particular thing. Is that clear to you? So these are the 2 points. Now, how do we find these points? That becomes a big problem. So one is graphical solution. You could graph and get the solution, correct?
Yes, sir.
You could do that. So x squared is greater than 3x plus 10. Once you do a graph, you can get the solution, right? Well, let's go for the method 2, which is algebraic.
Okay, sir.
So in that case, we can bring 10 to the left side. So if I bring 10 to the left side, I get x squared minus 3x minus 10 is greater than 0. Do you see that?
Yes, sir.
Now, x squared minus 3x minus 10. Can you factor this?
No, sir.
Why? 10 product and sum. Use product and sum. Minus 5 times minus 2. You remember?
Okay. Yes, sir.
So you could factor this as x minus 5. So because you want negative, you will use plus 2, right? So x minus 5 plus x plus 2 is greater than 0, right? So that is how you are going to factor it. Now, if you look into this parabola, then how will you find the solution? This is a parabola which will have 2 x-intercepts. One being at 5, the other one at minus 2. It opens upwards. So it will be drawn like this. Is that clear?
Yes, sir.
So this point being at plus 5, minus 2 and plus 5.
Okay, sir.
So the region where is this greater than 0 is beyond these points. Is that clear?
Yes, sir.
So you get your solution again, but algebraically, you have calculated the values exactly. You get the idea?
Yes, sir.
So you'll say x is less than minus 2 or union x is greater than 5 is your solution. On the graph, if you figure it out, this value will be minus 2 and the other value will be 5 if you draw the graph. Do you understand?
Yes,
so method 1, we use the graph to solve, and in method 2, we had algebraic solution. Is that clear to you? So you can actually solve your inequalities graphically or algebraically. Correct?
Yes, sir.
So that is what I wanted to teach you today, so that we can actually do these inequalities in many different ways. We also saw how do we work with inequalities when we are looking into single variable and also when we are looking
double
into double variable, right? So coming back to the beginning of our lesson, let me add a page here, right? So let me add a page here. So what did you learn today? So we're talking about inequalities. So if we have a single variable, in that case, we prefer to show our solution on a number line, right?
Yes, sir.
So on a number line, we could show a solution saying, well, it is between the two values, right? Where these could be included or these may not be included, right? If it is open circle, it really means this is, let's say this value is, let us say -3, and this value is 4. In that case, we are saying that the solution for this is x, which is greater than -3, but is less than 4, correct?
Yes, sir.
If we have a solution of a single variable inequality, kind of like this, where this point is, let's say 5, right? So in that case, we are saying that the solution is x is greater than 5, right?
Okay, sir.
On the other hand, if I have a line so that the solution is included and also greater than, let's say this point is 3, right? So we say x is greater than equal to 3. And on the other side, if we have something like this, we can have x is less than equal to, let's say this point is -4, so -4. So we could also have a solution something like this, correct? So in single variable, sir, the idea is we are representing the solutions on a number line, correct?
Yes, sir.
Now, if we have two variables, right? So we have two variables. In that case, it is like y is related with x, right? So y equals to, let us say we had 2x minus, let us say 4. That really means we have two lines, right? So when we say two variable inequality, in that case, we cannot have equal to sign. How we'll have a greater than or less than sign, right? Something like this. So let me rewrite this as greater than equal to. If I have equal to sign, it really means it is a closed region, right?
Yes, sir.
It means include the line. On the other hand, if I have an equality which is y is less than, let us say, x plus 4, in that case, we are saying it is open region.
Okay.
And less than means below the line. Line not included. Correct? In this case, closed region means include the line and because of greater than, above the line. Perfect. So that is how we could summarize what we have learned today as far as the inequalities are concerned. Correct?
Yes, sir.
Good. So I hope you have learned the concept. I'd like you to summarize today's learnings.
Okay, sir.
Stop sharing this, and I'd like you to summarize today's learning. So what did you learn today, Rohan?
Overall, in today's class, I've learned about an open and closed parabola.
Interval.
Interval in which how one would be dotted line, the other would be like a full line. I've learned the difference between inequality of one variable, single variable, and how we use a number line, and double variable as in graph.
Region, yes.
I've also learned about looking at and understanding the signals of greater than, less than, or greater than equal to, and less than equal to symbols.
Yeah. So if y is greater than, let us say 2x plus 3, in that case, which region are you looking into?
So y is greater than 2x plus 3?
Yeah.
Then I would be using a graph. So it would be an open graph going upwards.
Open region upwards above the line, line not included. Correct. If I have the equation x plus y less than equal to 10, in that case, what will be your solution?
X plus y less than equal to 10. I would still use a graph system because there's two variables and it will be going downwards.
Down, and the line will be included. So it will be a closed
region.
Correct. So in short, that is how we are going to do inequalities where two variables are involved. And linking those two variables, we are normally getting a straight line. We also did an example with non-linear function, which is a quadratic equation. Do you see that? So we had x squared plus something greater than something, right? 10 in that particular example. Now, those kinds of things we could even solve in different ways. We could write that as a quadratic equation greater than or equal to 0, right? Depending on, and then solve by that equation, find the exact value. Or we could split it into two functions, one being a quadratic, the other being linear. And then we can find the point of intersections graphically and get the solution. So there are different ways of solving our inequalities as we learned today, correct?
Yes, sir.
I'd like you to practice some questions from my playlist. I will share some with you, and then we'll move forward with more functions, especially the absolute function. So I want to actually teach you what is an absolute function and how do we use absolute function in inequalities. Is that okay?
Okay, sir.
Okay, so we'll end the class here today, and I'll share with you some links. Practice with those. Okay, thank you.
Okay, thank you very much, sir. Have a great day.
You too.
Bye.